I'm going to suggest to you that there are three logical possibilities. Possibility number one is that something might be logically necessary. If we say that something is logically necessary, we're saying this is required. This is logically required. It has to be this way. It can't be any other way. A square has to have four sides. If it's a figure with any more or fewer than four sides, it is not a square. It is logically required that a square be a four-sided figure. You might think back to the statements we looked at earlier in the semester called tautologies. Those were those statements where the column underneath the main operator always had a truth value of true. They were never false. Okay? On the other hand, something might be said to be not logically necessary. Something that's not logically necessary can certainly be a certain way, but it doesn't have to be. Okay, so if I tell you I'm thinking of a number greater than 5, it's not logically necessary that I be thinking of the number 10, but it's certainly possible I could be. I could be thinking of 100, I could be thinking of 6. It's not necessary that I be thinking of a particular number if all I've told you is I'm thinking of a number greater than 5. The only thing that would be logically necessary is if I said to you I'm thinking of a number identical to 5, I'd have to be thinking of a number identical to 5. Okay? Otherwise what I'm saying isn't true. So not logically necessary. Things that could be a certain way, but they don't have to be. So think back to those contingent statements that we explored. Those are the statements where the column of truth values underneath the main operators, they varied. On some lines the truth value was true, and on some lines it was false. It just kind of depended on the way that things were arranged on those lines of the truth table. And finally, we have something that could be said to be logically impossible. This is just something that can't be. We can't have a round square or a square circle. This is logically impossible. Okay? And you might think back to the statements we characterized as self-contradictory statements. Those were the statements that had the truth value of false underneath the main operator all the way down. They were never true. Okay? Now we can take these three ideas and we can kind of apply them to our symbolized statements that we're working with. So that if I give you the statement B dot C and I tell you the truth value of that dot is true, and you consult your conjunction truth table, is there anything that's required or impossible about B and C based on this dot being true? And if you're saying, well, yeah, B and C have to be true if the dot is true, because when I look at this truth table, I see that it's only on line 1 that the truth value of the dot is true, and that's when the left and the right-hand side are both true. So if you tell me that that dot is true, I know it's logically impossible for either B or C to be false, and it's logically necessary for B and C to be true. What about a statement like this, B wedge C, and I'm telling you the truth value of the wedge is false. Is there anything that's logically required of B and C? Is there anything that's logically impossible for B and C? And you're saying, well, yeah. I see right down here on line 4 that the wedge is false when what appears on the left-hand side and the right-hand side are both false. So B and C are required to both, they're logically required to be both false, and it's logically impossible for either one of them to be true, because I can see here on lines 1 and 3, if one or both sides of the wedge is true, then the wedge is true, and you're telling me the wedge is false. So it's logically necessary for B and C to both be false. Now what about a statement like this? B horseshoe C. And I'm telling you that horseshoe has a truth value of false. Then you're going to say, okay, then that means that B has to be true and C has to be false, because a horseshoe is false only when what appears on the left-hand side is true and what appears on the right-hand side is false. And finally, what if I give you a statement like this, B triple bar C, and you pull up your biconditional truth table, and you're looking here and you can see there's something that's logically necessary, something that's not logically necessary, and something logically impossible about this statement. One thing that's logically necessary is that B and C cannot have the same truth value, because if we look at our truth table, particularly lines 1 and 4, we see that any time what appears on each side of the triple bar has the same truth value, the triple bar itself is true. And here we're being told the triple bar is false. So it's logically necessary that B and C have different truth values, and it's logically impossible for them to have the same truth values. So that means that either B is true and C is false, or B is false and C is true. But it's not logically necessary that B be true or false. It's just logically required that it be the opposite of whatever the truth value of C is. Okay,